Hello everybody, welcome to session 2 of chapter classification of elements, and today we will be explaining uh, 2n square rule and subcell rule, and similarly we'll learn how to calculate valency of an atom, and we will be differentiating atom from ion. This 2n square rule helps to know how much electrons that can be carried by an orbit. So here this n represents number of orbit. So if we apply this formula here, then k cell means first orbit. This is k cell, and this is called L cell, M cell, N cell, and so on. So the first orbit, let's calculate how much it can carry the electron. So formula is 2n square, and here 2 is same, and here n represents number of orbit. So since this is first orbit, so value of n is 1. So 1 is square, so 2 electron. That means the k cell of first orbit can carry 2 electrons. So here you can see it has 2 electrons. Similarly, let's go to second cell. It is also called L cell, and if you apply the same formula to n square, so n means 2, so 2 square means 4, 4 times 2 means 8. That means the second orbit can carry 8 electrons. So if you count here, it will be 8 electrons here. M cell, third orbit, if we apply the same formula, then it can carry 18 electrons. Similarly, N cell means the fourth orbit here. If you apply the same formula to n square, then it becomes 32 electrons. That means from here, what is the conclusion is that the first orbit can carry 2 electrons, second orbit can carry 8 electrons, third orbit can carry 18 electrons, and the fourth orbit can carry 32 electrons. And let me tell you, this rule is applicable only till fourth orbit. And here this outermost orbit of an atom is known as valence orbit or valence cell, and the electrons present in the outermost orbit are known as valence electrons. Now let's talk about subcell. So this is a model of atomic structure. So the central part of atom is called nucleus, and around the nucleus we find electrons revolving in particular space, and that is space where there is maximum chance of finding the electron, that is called subcell or orbitals. We can also call it orbital, and by the combination of many subcell, cell or orbit is made up of. So there are four types of subcell or orbitals, namely S, P, D, and F subcell. And S subcell can carry 2 electrons, P subcell can carry 6 electrons, D subcell can carry 10 electrons, and F subcell can carry 14 electrons. That means here, if you go on adding 4 and 4, then you will get the number of electrons. Like example, 2 plus 4 is 6, 6 plus 4 is 10, 10 plus 4 is 14. In this way, we can guess the number of electrons carried by respective subcell. And as I told you, the orbit is made up of subcell or orbital. So here, the k cell or first orbit is made up of only s orbital, whereas L means second orbit is made up of s and p orbital. Similarly, M cell or M orbit is made up of s, p, and d, and from n orbit onwards, all are made up of these s, p, d, and f orbitals. So if we check here, then S subcell, as I told you, S subcell can carry 2 electrons, means yes, since it is having only S subcell, so it has 2 electrons, means the first orbit can carry 2 electrons. If we go to second orbit, then it is made up of S and P orbital, and S can carry 2 electrons and P can carry 6, so altogether 8 electrons. That means second orbit can carry 8 electrons, which we have calculated by 2n square formula in previous slide. Similarly, M cell, the third cell, it is made up of s, p, and d orbital. So if you calculate the total electrons carried by it, then s can carry 2, p can carry 6, and d can carry 10. That means 18 electrons. And fourth orbit onwards, then what you see, they all are made up of same orbitals, sp, d, and f. So if you count, it comes 32 electrons. That means, according to soft shell rule, first orbit can carry 2 electrons. Why? Because it is made up of only s sub shell. Second orbit can carry 8 electrons because it is made up of s and p orbital. em cell can carry 18 electrons because it is made up of sp and d orbital. And the fourth orbit onwards, they all can carry 32 electrons because they are made up of sp, d, and f orbitals. So here, if you want to get the electronic configuration, then as I told you, first orbit here, digit represents number of orbits. So 1 means first orbit. So first orbit is made up of s orbital. So we have written s orbital. Second orbit, so this 2 represents second orbit. So second orbit is made up of s and p orbital. So we have written 2s and 2p. Third orbit, 3, 3, 3, this is number of orbit, and it is made up of s, p, and d. That's why we have written 3s, 3p, and 3d. Similarly, fourth onward, it is made up of s, p, d, f orbital. Now, if you draw the downward arrow, then what you see is, if you draw the downward arrow, then that shows the uh, path for electronic configuration. So here, the first arrow is touching just 1s, so we have written 1s, comma. Second orbit is touching 2s, so 2s. Third orbit is touching 2p and then 3s, so 2p and 3s. And fourth is touching 3p and 4s, so that's why we have written 3p and 4s. And fifth is touching 3d, 4p, and 5s, so we have written 3d, 4p, 5s, and so on. If you go on, you can find the electronic configuration. But here, as a students of class 9 and 10, just learning up to 3D is enough. So when you are writing the electronic configuration, you need to know where to put comma. So whenever you change the orbit number, you are supposed to keep the comma. Like example, you have 1s and it is 2s, means first orbit to second orbit, that means put the comma. But here 2s and 2p means it is within the same orbit, so no need to put comma between. But when it comes from 2p to 3s, again number of orbit has changed, so again we are putting comma. 3s to 3p, same orbit, so no need to put comma here. And 3p to 4s, comma has to be kept because number of orbit has changed. Similarly, 4s to 3d, again we'll put comma because the number of orbit has changed. So as a students of class 9 and 10, just learning up to 3d is enough. So what is it? 1s, 2s, 2p, 3s, 3p, 4s, 3d. How did you get this? From this structure. So remember this electronic configuration: 1s, 2s, 2p, 3s, 3p, 4s, and then 3d. If you know up to 3d, it is more than enough for your level. Now let's check here. So electronic configuration of first 20 elements we are writing here. So you can see hydrogen has only one electron, and we are following this configuration. So 1, yes, and since hydrogen carry only one electron, so we write here 1. This power represents number of electron. Though it can, s orbital can carry 2 electrons, but since hydrogen has only one electron, so we'll be writing here 1. Now when you come to helium, then it has 2 electrons, so 1 is 2. Now lithium is 1s and 2s. If we check here, the format is 1s and 2s. So first orbit can carry 2 electrons, but it has 3, so you need to write 2s, and we'll write one more. Though it can carry 2 electrons, but it has only 3 electrons, that is why here 2 and here 1. In the beryllium, 1 is 2, and then it has 4 electrons, so 2 electrons remain, so 2s2. In the same way, if you go for chlorine has 17 electrons, so we'll follow this exact format. So you can see 1s, 2s, 2p, 3s, 3p. So 1 is, it can carry 2 electrons because it is s orbital. 2s, it can also carry 2 electrons. It has total 17 electrons, so you have to go on adding more orbitals. So 2p, 6, because p can carry 6 electrons, so it has become total 10. Still it has 7 electrons, that's why we will further continue. So 3s2 and means 12, so still it has 5, So 3p5, though it can carry 6 electrons, but since only 5 electrons are remaining, that's why we are writing 5. In this way, you should practice to write electron configuration, but the format is always same. If you learn this format, then it will be easy to write electronic configuration. Uh, Naturally, all the atoms are not all, most of the atoms are unstable. The reason is the outermost orbit is not completely fulfilled by electrons. Example, you can see oxygen. This is the second orbit and it can carry 8 electrons, but it has only 6, means its outermost orbit is not fulfilled by electrons. Similarly, if you go to sodium, then this outermost orbit can carry 8 electrons, but it has only 1. That means it is also not completely fulfilled by electrons. So here oxygen and sodium both are unstable. But if we come to helium and neon, then helium, this is the first orbit, so it can carry 2 electrons, and you can see here helium outermost orbit is completely fulfilled. So such atom is stable. Similarly, neon, second orbit can carry 8 electrons, and here if you see it has 8 electrons, means here helium and neon, they are stable atoms, whereas oxygen and sodium are unstable atoms. The reason is outermost orbit is not completely fulfilled by electrons. So here the capacity of that orbit to carry electrons, like example, the first orbit can carry 2 electrons, and this capacity of carrying 2 electrons by the first orbit is known as duplet. Similarly, the second orbit onwards, they can carry 8 electrons, and this capacity is known as octet. So that's why here you can see duplet and octet. So those elements which are in duplet or octet state, they are called stable atoms. Like you can say helium and neon. Helium is in duplet condition, whereas neon is in octet state. So since helium and neon, they are in either duplet or octet state, so they are stable. Whereas oxygen and sodium, they are not stable. I mean unstable, because they are not in octet state, because outermost orbit is not having 8 electrons. So means oxygen and sodium, they are not in octet state. That is why they are unstable, or they are very active element. So to be a stable, the atoms have two ways. One is completely fulfilling the outermost orbit. Like example, oxygen, you can see here, it has 6. So if it receives 2 electrons from outside, then it will be completely fulfilled by electrons. So in that case, it become octet, and that time oxygen can be stable. Or completely vacant the outermost orbit by losing electron, like sodium. Sodium has 1 electron here. So to completely to be a octet state, it needs 7 electrons. But to completely vacant, it has to throw 1 electron. So here, losing 1 electron is more easy than gaining 7 electron. That's why sodium prefers to lose electron, means it tends to make it vacant by losing electron. So in that condition also, it can be stable. So there are two ways, either gaining electrons and completely fulfilling the outermost orbit, or completely vacant the outermost orbit by the losing electron. And here helium and neon, since they are either duplet or octet states, so such elements or such atoms are called inert gas or noble gas or ideal gas. So here definition you can check. The atom which is in duplet or octet state is known as inert gas. For example, helium, neon, argon, etc. And since the outermost orbit is completely fulfilled by electrons and they are stable, stable means inactive, so these elements do not take part in any chemical reaction because they are duplet and octet, and they do not take part in any chemical reaction. But here if you check sodium and oxygen, they are not in octet or duplet state, so they are unstable, means they are active, and because of activeness they take part in chemical reaction. Now if you go to another part of the atom, naturally almost all atoms are chargeless or neutral. The reason is we have discussed in previous previous session that all the atoms have equal number of electrons and protons. And if you remember, electrons they carry negative charge, and protons which lie at the center has got positive charge. And since all the atoms have equal number of protons and electrons, what they do, they cancel each other strength, and because of that all the atoms are neutral. Like example, you can see oxygen. Naturally oxygen has got 8 electrons and proton also 8. So proton 8, oxygen electron 8 means they are equal in number plus opposite in strength, and because of that they cancel each other strength. That's why oxygen is neutral. Same case in sodium. Naturally sodium has 11 electrons and proton also 11. So when electrons and protons are equal in number, and since they have opposite strength, they cancel each other strength, and because of that they are also chargeless. Same case with helium and neon also. Helium has 2 proton and 2 electrons, so they cancel each other strength. Neon has got proton 10 and electrons so 10, so they cancel each other strength. So in this way almost all the natural atoms are neutral charge because they have equal number of protons and electrons. Here, though oxygen and sodium, they are neutral charge, but they are very active, unstable. So due to that, what they do is either they completely fulfill the outermost orbit by electron, or they either completely vacate the outermost orbit by losing electron. And when they do so, then what happens? The electron number and protons number will not be equal. So what happens is when unstable but neutral atom lose or gain electron to become stable, then in that condition I already told you electron and protons number are not equal, and in that case they gain charge. So in that case, if atom loses electron to become stable, losing electron means automatically what happens? The protons number will be more, and since protons number are more and protons carry positive charge, so that atom get positively charged. Similarly, if atom gains electron, so when gaining electron, then the number of electron will be more, and when electron is more, and since electron carry negative charge, so atom will be negatively charged. Naturally, electron protons number are equal, but what happens? They are unstable. So to become stable, what they do? Either they lose electron or gain electron. And if they lose electron, protons become more, and when protons become more, it will be positive charge. And if they gain electrons, electrons become more, and when electrons become more, then that atom become negative charge. And as I told you, the unstable atoms they lose or gain electrons to become stable, and after losing the or gaining the electron, they combine with the another atom. So that combining capacity of that atom is known as valency. And how do we determine? We determine by counting number of electrons lost or gained to become stable. Like here you can see oxygen. Oxygen has got 6 valence electrons, and to become stable it gains 2 electrons, and after that it goes to octet state. So since it has gained 2 electrons to become octet state, its valence is 2. And here sodium, you can see sodium has 1 valence electron. So to become stable, what does it do? It will lose this electron. So since it has lost 1 electron to become stable, its valence is 1. That is why question may come, why the valence of sodium is 1? So what will be answer? As sodium loses 1 valence electron to become stable, its valence is 1. Similarly, why valence of oxygen is 2? Since oxygen gains 2 electron to become stable, its valence is 2. Okay, so what does the atoms do? They lose or gain electrons, and when they lose or gain electrons, they become charged. Like here, oxygen is gaining electrons, so when electrons are gained, electrons are more in number, and since electrons carry negative charge, and here electrons are more in number, so oxygen is negative charge. And in the case of sodium, sodium is losing electron. So when sodium lose electron, that means protons are more. And since protons are more, so it gains positive charge. So what is iron? Though charged atom only is known as iron. And it is of two types, cation and anion. And that positively charged atom is known as cation. So here sodium ion is cation because it is positively charged. And how it is formed? By losing the electrons. An example is sodium, and number of charge depends on number of electrons lost or gained. Like here sodium is losing one electron, so plus 1 plus. And here you can see magnesium. Magnesium has two valence electrons. So to become stable, it will lose that two electrons and it becomes stable. So since it has lost two electrons, so its number of charge is 2 plus. Similarly, the negatively charged here, oxygen is negatively charged atom. So the negatively charged atom is known as anion. And how it is formed? By gaining the electron. An example, since oxygen is gaining 2 electrons, so number of charge is 2 minus. And chlorine, if you remember, chlorine has got 7 valence electron. So to become stable, it will gain 1 electron, so 1 charge, 1 negative charge. And nitrogen has got 5 valence electron, so it will gain 3 electrons to become stable, so it has 3 minus charge. Now differences between atom and ion. So atom, you know that all the natural atoms are chargeless because natural atom has equal number of protons and electrons. Whereas ion, it is charged because either they have more protons or more electron. That is why it is charged. In atom, equal number of protons and electrons, but in ion, protons and electrons are not equal. That's why they are charged. An atom unstable because the outermost orbit is not completely fulfilled by electron. But ion, it is stable because they are either duplet or octet state. Similarly, cation and anion. Cation is positively charged ion and anion is negatively charged ion. And the reason of having positive charges, it has more proton than electron. And the reason of having more negative charges, it has more electron. So the molecule, the smallest particle of substance is known as molecule. So if you go on breaking down any substance, then at one point you cannot break it further. So that very smallest particle of that substance is known as molecule. And molecule is stable, and that is why it can exist in free state. And the molecules of an element contains one or more similar atoms, because since it is made up of it is of element, and you know that element is the pure substance. That is why it contains one or more similar atoms. Example, monoatomic molecules. So since it is mono means only one kind of atom, so this kind of molecule has got only one kind of only one single atom, like helium, neon, argon, krypton. They are stable, and that's why they are just single. But diatomic molecules, it has got two similar atoms like S2, O2, N2, I2. So here hydrogen, S2 means there are two hydrogen, O2 means two oxygen, N2 means two nitrogen, and I2 means two iodine. Triatomic molecules, this contains three different atoms like ozone gas. So it is present in atmosphere, if you remember. It has three oxygen atoms. The molecules of compound. So compound is made up of different elements. That is why it contains different type of atoms. So here it doesn't have any monoatomic molecules. So it will begin from diatomic molecules. So it contains two different atoms like sodium chloride, CO1, sodium is one, chlorine is another atom. Magnesium oxide, magnesium is one atom, oxygen is another atom. Aluminum nitride, aluminum and nitrogen, they are two different atoms. So if a compound has got two different atoms, we can call it diatomic molecules. Now triatomic molecules, it contains three different atoms. Like example, water, H2O. Here two hydrogen and one oxygen means total three atoms. Sulfur dioxide, here you can see sulfur is one, two oxygen, so it is also three atoms. So in this way, molecules can be categorized. Some of the elements like iron, copper, mercury, here you can see they have valency more than one. Before we discuss that, the valency these depend on number of electrons lost or gained. But there are some elements they have more than one valency, and this kind of condition is known as variable valency. Like iron has valency 2 and 3, copper has valency 1 and 2, mercury has valency 1 and 2, lead has valency 2 and 4, tin has valency 2 and 4, and manganese has valency 2 and 4. So these valencies you have to remember. Now this is the table showing valencies of different elements. So valency ranges from 0 to 4. So the one who got valency 1, these atoms are called monovalent, divalent means 2 valency, 3 valency, and 4 valency. So these elements have 0 valency: helium, neon, argon, krypton, xenon, radon, oxidation. These elements valence is 0 because they are, if you remember, they are ideal gas. So they are in octet or duplet state. So they do not lose or gain electrons to become stable. So since they do not lose or gain electron, their valence is 0. Whereas these elements, they lose or gain one electron, that's a valence is 1. And here, if you remember, this is variable valency. The copper having one valency is called cuprous, and the copper having two valency is called cupric. So here one clue I want to share with you. If valence is less, then you add suffix OUS, and if more valency, then add suffix IC. For example, you have mercurous and mercuric. Mercurous valency 1, mercuric valency 2. Here less valency is OUS, mercurous, and here more valency is mercuric. Similarly, here ferrous and ferric. These are the two valency of iron. Here this iron has less valency, so ferrous, OUS suffix. And here this iron has more valency, so ferric, suffix is IC. Same case is applied in other case too. So remember this thing. So divalent means these elements have got two valency, and these elements have three valency, and this carbon and silicon they have four valency. So remember these valencies. With this, thank you so much.